All right, hi guys. So I'm going to do some stoichiometry revision with you, and just to refresh your memory. So let's just go through starts. So calculate the mass of hydrochloric acid needed to react with calcium hydroxide to produce 30 grams of calcium chloride. Now notice what I didn't give you this time. I didn't give you a chemical equation. So look, you will be given a chemical equation when you are doing this kind of thing, but remember that you can also be asked to do chemical equations as a separate question. So let's just look at this. So it's hydrochloric acid, HCl, needed to react with calcium hydroxide. So calcium hydroxide, remember the hydroxide is a -1, so you need 2 of the hydroxides with your calcium to give you and it says calcium chloride. So I've given you the salt here. Remember, an acid and a base gives you salt and water. So to give you calcium chloride, so CaCl2 plus water. Now, it didn't say anything about water, but you do need to include the water because you need it to balance your equation. So an acid and a base gives you salt and water. So I know now that it's 2 HCl's to 2 waters. So there are our ratios. Okay, so we are looking for, I didn't make enough space for myself to put, so I'm going to do it in a red color here because I'm looking for that one. Okay, and what we've been given is 30 grams of calcium chloride. Well, we need to make 30 grams of calcium chloride, and so we want to know how many grams of hydrochloric acid do I need to react with to make 30 grams. Okay, so we've got this information. We use our moles equation. All right, so number of moles is equal to 30 grams divided by, and the molar mass for calcium chloride is 111. So my moles work out to be 0.27. Now remember, we are using the mole ratio here to get the number of moles of HCl. So it is 2 to 1 ratio. I hope you can see that, 2 to 1 ratio. And so we know that we divide by the first times by the second. So you're timesing it by 2. So what happens is that I'm just going to take it on to the top here. We got to 0.54 moles of this one. If we use our ratio, remember that is what comes from that. So we can now use our mass molar equation again, and we get 0.54 is equal to the mass of a molar mass, and HCl is 36.5. So the mass lands up being 19.71 grams of HCl is needed to produce 30 grams of calcium chloride. Okay, let's take a look at the next one. So the next one says, calculate the volume of ammonia gas produced when 56 decimeters cubed of hydrogen reacted at STP. Very important letters, STP, because why? We can use molar volume here. Okay, so the thing at STP is that it will use Avogadro's law. So Avogadro's law says the number of moles will be the same at STP of any of the gases. So ammonia, let's just take a look here. So N2 plus, this is the Haber process that we use to make ammonia. Okay, and now I've balanced the chemical equation already. Now the thing about these is that they are all gases. Now because they are all gases, you don't need to work out the moles and compare the moles and then get back to volume. You can use the molar volume at STP if they've given you a volume, but not all the reactants and products are gases. If they're not all gases, you can't use this method. But if they are all gases and it is at STP, then you can compare volumes. If you're given a volume and you can work out your moles with the molar volume, but let's say, for example, ammonia was a liquid or an aqueous or something, you can't use this method. You'd have to work out your moles, do your ratio, and get your moles again. Okay, so what we're going to do here now is it says calculate the volume of ammonia gas produced when 56 decimeters cubed of hydrogen. Okay, 56 decimeters cubed of hydrogen. So because all of them are gases, nitrogen is a gas, hydrogen is a gas, and ammonia is a gas, we can compare volumes. This is the only other thing you can compare other than moles when you've got this. And it has to be at STP, and it has to be all gases. Okay, so now because it's like that, I can really just go, well, it's a 3:2 ratio. You work out your ratio and you land up with 37,33 decimeters of ammonia produced. Okay, the last one I'm going to do with you, just to help you remember, is I'm talking about a titration here. We're going to do titrations properly in grade 12, but the question involves a titration. So I just want to let you know what a titration is. So a titration is a technique where a solution of known concentration, we call this the standard solution, is used to find the unknown concentration of another solution. Now this is usually used with acids and bases. And like I said, I will do that with you next year. So acids and bases. But we can use these quantities to work things out. So here we have a titration reaction occurs between sulfuric acid and sodium hydroxide. Okay, so again, I haven't given you the equation, so I'm going to do it with you. So sulfuric acid is H2SO4 plus, and I'm just going to give you the balanced chemical equation. Remember, you have to balance it. Sodium hydroxide. It will give you a salt, and the salt will be a sulfate. I don't know if you remember from last year. The salt will be a sulfate, and you'll take the metal from the base. So you've got sodium sulfate, which looks like that, plus your water. Don't forget, water is always a product here. So let's just carry on reading. So 30 centimeters cubed. Oh my word, I want to puke because it says centimeters cubed and we need decimeters cubed. You divide by 1,000. What I normally do is I go back 3 spaces, 3 decimal places, because it's 1,000. So it's 0,03 decimeters cubed. Okay, of sodium hydroxide. Okay, so our volume, let's change the color again. So the volume is equal to 0,03 decimeters cubed, and my concentration is equal to 0,56 mole per decimeter cubed. Okay, so that's what it says there. Mole per decimeter cubed is the concentration of that. It says, so 30 centimeters cubed of sodium hydroxide of concentration 0,56 mole per decimeter cubed is used to neutralize 18 centimeters cubed. Again, puke, you want to change that to 0,018, divide by 1,000 decimeters cubed. Okay, so what we've got here is a volume of 0,018. 18 decimeters cubed. Okay, so, and what are we looking for? We are looking for the concentration of sulfuric acid. So I have information here, and I'm missing information here. I need to find that concentration. So I have enough information here to work out the moles. Okay, now notice I can't compare volumes here like I did in the previous one, because these are not gases and it's not at STP. So I can't use the volumes this time. But what I can do is I can work out number of moles. So I'm going to just move it up a bit to give us a bit more space here. So I can, go with C is equal to N over V. That's my concentration equation. We have our concentration of 0,56. We have our volume of 0,03. And that lands up with a concentration, moles of, that lands up with moles of 0,0168. Okay, now because it's a 2-to-1 ratio, so 0,0168, I can then go, all right, I'm now working out that, and it is a 1-to-2 ratio, divide by the first, times by the second. So that means that you're going to divide it by 2. And I land up with moles of H2SO4 as being 8,4 times 10 to the minus 3. Okay, so there's my number of moles. I know I have a volume. I want concentration. So I can then use that equation again, and I substitute in my number of moles and my volume is 0,018, and my concentration lands up being 0,47 moles per decimeters cubed. And there we have it. Okay, you've got some think tanks to do. It looks like a lot, I know it does, but it's also, one thing, it's revision, and also for every think tank I've given you 1 or 2 equations. So I want you to just please try these exercises today, because it's very important for your matric exams. And then yeah, I think that's all I wanted to say to you. Oh, what you can do is I downloaded Snaplify, the teacher's guide for the grade 10s. I'm going to check if there's a teacher's guide for the grade 11. So if you want to download that teacher's guide as well from Snaplify, and you can then do all of them and make sure you've got all the answers. So yeah, so these are just the ones that I want you to do. So this is the minimum amount I want you to do. You need to practice this stuff. Okay, love you all.